So guys, the another compound of hydrogen is hydrogen peroxide. It's very important a laboratory reagent. Now, hydrogen peroxide can be prepared by various methods. The one is electrolysis of concentrated sulfuric acid, that is 50% sulfuric acid. Sulfuric acid on electrolysis dissociate as H plus and HSO4 minus. At anode, the oxidation of this HSO4 is taking place, forming peroxide disulfuric acid. Now, peroxide disulfuric acid can be removed by distillation, and which on further dilution gives you Carrot's acid or peroxysulfuric acid H2SO5, which on further dilution gives you hydrogen peroxide and sulfuric acid, which we can recycle, reuse for the preparation of hydrogen peroxide. Now, this is one method. The second method is ethyl anthraquinone, hydroxyanthraquinone or quinol, anthraquinol. Now, 2-ethyl anthraquinol on oxidation using palladium as a catalyst gives you hydrogen peroxide, and the byproduct obtained is 2-ethyl anthraquinone. Now, 2-ethyl anthraquinone can be further reduced in the same reaction by using palladium, gives you quinol, anthraquinol, which further undergo oxidation giving a hydrogen peroxide. So, this is a very important reaction. This is a famous commercial method for the preparation of hydrogen peroxide. In a laboratory, hydrogen peroxide can be prepared by using sodium peroxide, that is called the Muggs process. Sodium peroxide is treated with sulfuric acid, gives you hydrogen peroxide. Another method is barium peroxide is treated with sulfuric acid, giving you a hydrogen peroxide. All these methods, the best method, we can't say that's the best method, all the methods have some of the drawbacks, but this method is considered to be one of the best methods because hydrogen peroxide can be easily distilled out. Now, hydrogen peroxide, if we consider the oxidation number of oxygen, that is -1, so it can undergo oxidation as well as it can undergo reduction. So, hydrogen peroxide acts as oxidizing as well as reducing agent. Hydrogen peroxide is unstable at room temperature. Even if we keep open, it undergo decomposition, giving you hydrogen, water and oxygen gas. The decomposition of hydrogen peroxide can be enhanced, can be increased by adding certain metal ions. Now, hydrogen peroxide is a weak acid, rather it is a diprotic acid. So, it dissociates like this way and 2H plus ion, therefore it is dibasic acid. Hydrogen peroxide in acidic medium act as an oxidizing agent by gaining electrons like this way, as well as it act as a oxidizing agent in an alkaline medium also. So, these are some of the reactions which act as where the hydrogen peroxide act as oxidizing agent. So, acidified ferrous sulfate gives you ferric sulfate, potassium ferrocyanide gives you potassium ferricyanide, potassium iodide liberates iodine, potassium dichromate gives you CrO5. Okay, now here in a CrO5, the oxidation state of chromium is 6 only. It has a butterfly structure where there are 2 peroxide linkages. So, if we in case of CrO5, which has a butterfly structure, we can draw the structure like this way. So, there are 2 peroxide linkage and the oxidation state because of that oxidation state of chromium becomes +6. It also oxidizes lead sulfide to lead sulfate, hydrogen sulfide to sulfur, which is colloidal sulfur, sodium sulfide to sodium sulfate. Now, whatever the reactions we have seen till here, they are actually reactions involving acidic medium. Here onwards, the reactions involving alkaline medium, where sodium sulfide gives you sodium sulfate, potassium nitride gives you potassium nitrate, manganese sulfate gives you MnO2, manganese dioxide. In all the cases, if you observe carefully, even if the medium is changing, hydrogen peroxide act as oxidizing agent. Now, the product form depends upon how much electron oxygen is accepting from the other element. So, in some cases like these reactions 1, 2 and 3, these reactions are normal reaction as that of the normal oxidizing. So, Fe2 plus changes to Fe3 plus, Fe2 plus changes to Fe3 plus, I minus changes to I0, Cr6 plus. Now, if you observe carefully, Cr6 plus changes to Cr6 plus only, but here the oxygen is undergoing reduction. PbS sulfur minus 2 changes to plus 6, minus 2 changes to 0. So, this way we can get the idea where the hydrogen peroxide act as oxidizing agent or reducing agent. These reactions are important in stoichiometry also. Now, as I already said, hydrogen peroxide, the oxidation number of oxygen in hydrogen peroxide is -1. So, it can act as an oxidizing agent as well as it can act as a reducing agent. So, these are some of the reactions where hydrogen peroxide act as a reducing agent. Here also it is irrespective of the medium. Definitely the products obtained depend on the medium. So, hydrogen peroxide in acidic medium, potassium permanganate gives you manganese sulfate, MnO2 changes to MnSO4, O3 changes to O2, Cl2 changes to Cl minus, HOCl, so +1 is the oxidation state of chlorine, that changes to -1. So, up to here we have a reducing action in acidic medium. Now, here onwards we have a action of hydrogen peroxide in alkaline medium. So, KMnO4 changes to MnO2. Just see here, KMnO4 changes to MnSO4. Here we have a +4 oxidation state, here we have a +2 oxidation state. Ferric sulfate changes to ferrous sulfate. Silver oxide actually regenerates silver. Now, that silver is a colloidal silver. Lead dioxide gives a lead oxide. So, these are all reducing action. Hydrogen peroxide is also very important for organic reactions also. It directly gets added across the double bond, and this is the reaction where ethylene reacts with hydrogen peroxide, giving you ethylene glycol. Hydrogen peroxide also acts as a bleaching agent, and that bleaching action is because of liberation of nascent oxygen. So, that nascent oxygen combined with the unsaturation part of color, and because of that the unsaturation gets disturbed or destroyed, and therefore the colorless compound becomes a colored compound becomes colorless. Okay, so here the bleaching action is because of the oxidizing action of hydrogen peroxide. Now, if you see the structure of hydrogen peroxide in a book, they have given you a open book structure. So, if you observe carefully, hydrogen peroxide H1 OH bond on one arm of the one page of the book and another OH on other side. Okay, hydrogen peroxide in a pure form is a viscous liquid, but its concentration is measured in various ways: the percentage strength, volume strength and normality. So, we have already solved a problem based on the strength of the hydrogen peroxide in a stoichiometry. So, in and all, in this chapter, especially in a hydrogen, what kind of a questions will be asked? Most of the time the questions are in combined with stoichiometry and hydrogen peroxide, that is percentage strength, equivalent weight, normality and volume strength. So, they are very important with respect to the stoichiometry. Otherwise, from this chapter there are very few questions or a rare question asked, because in this chapter the theory is less, the number of reactions are more, and all those reactions we have already discussed, rather we are discussing in a salt analysis also in a qualitative analysis also. Now, one of the part which is remaining from this chapter, that is different types of a hydrogen. Now, since hydrogen contains one electron, the nucleus are impacting each other in case of dihydrogen. So, their nucleus has a particular spin. Now, that spin may affect some of the properties. Sometimes two nucleus have a same spin, or sometimes two nucleus have opposite spin. Depending upon, they are called as a orthodihydrogen and paradihydrogen. So, this is all about this chapter. If you want to emphasize more on this chapter, the important part from this is hydrogen peroxide and dihydrogen. So, there we have to focus more because the questions will be asked on that. One more topic that we will be discussing in a electrochemistry also, that is hydrogen oxygen fuel cell hydrogen economy. We can generate electricity by using hydrogen oxygen fuel cell, where hydrogen acts as a fuel, and in this way, instead of burning hydrogen and generating energy, it is very easy to get electricity by using hydrogen oxygen fuel cell. So, this is all about this chapter hydrogen. Since I already told you, here we have to focus only on few of the concepts because there are not much question asked in JEE also. So, more focus on S block, alkali metals and hydrogen peroxide. These are the two key important concepts we have to remember and we have to study. Thank you very much.